Hello everyone, you are welcome to my YouTube channel Study Maths with Asif. So friends, if you are new to this channel, kindly subscribe the channel and hit the bell icon for the latest videos and updates. So friends, let's start the video. Here I will talk about asymptote of a curve. Right, I will discuss its definition. I will solve some questions based on it. Also, I'll talk about asymptotes parallel to the coordinate axis. Only two topics I will cover in this video. First, definition of the asymptote to the curve and asymptotes parallel to the coordinate axis. Only two areas will be covered here. So let's see, the definition of the asymptote. So if you look at its definition, right? So here asymptote is a straight line. First, you should keep in mind. So a straight line is called an asymptote to the curve. Suppose we have a curve y equals to fx. This is the curve y equals to fx. So this straight line is called asymptote to this curve, right? Or we write the equation of a straight line as y equals to mx plus c. So this straight line will be called asymptote to a curve y equals to fx if the distance pm, or we can say this is the perpendicular distance from the point P to M. If this distance you see, right, tends to 0, you understand this is the limiting case. It will never 0, tends to 0, right, as P goes to infinity along the curve. So that means, right, this comes close to the curve when P goes to infinity along with the curve. So you understand what is the asymptote. So in other words, asymptote is a straight line, right, to a curve if the distance between the curve and the straight line goes to 0 as the point along with the curve goes to infinity. Then this straight line is called an asymptote. So it is not correct to say it's tangent at infinity, because whenever we talk about infinity, it is meaningless in mathematics. It has no meaning. So to say it's tangent at infinity, it's not appropriate. So always keep in mind, right, the distance between the curve and the straight line goes to 0 as P goes to infinity along with the curve. Then this straight line is called an asymptote. That's it. So hope you understand the definition of the asymptote. If you don't follow the definition, please repeat this video, right, once or twice and so on, right, until unless you appreciate the main definition of the asymptote. So I hope you understand. Now let's move on. I wish to discuss working rule here in the case when we talk about asymptotes parallel to the coordinate axis. Here, so coordinate axis means we have x-axis and y-axis. So how to calculate the asymptotes parallel to the x-axis and parallel to the y-axis? So first thing first, we should keep in mind, right, with linear factors. Linear factor means degree should be 1 of the coefficient of x. Here degree should be 1 of the coefficient of y. Now please read parallel to x-axis, we calculate the asymptotes parallel to x-axis, right, by equating to 0 the linear or real linear factors in the coefficient of highest parts of x in the equation of the curve. That's it. Then we calculate parallel asymptotes to x-axis. Similarly, the parallel asymptotes to y-axis can be calculated in the same way. Here we have to find out the linear factors associated with the highest power of y, and we equate to 0, right? So I will discuss this with the help of an example, then right, it will be crystal clear. Now let's see the example based on, right, the asymptotes to the coordinate axis. Now you see, parallel to the coordinate axis we have to calculate. These are two curves, first example and second example. So if you repeat these working rule here, so we have to identify the linear factor, right, associated with the highest degree of x and highest degree of y. So if I ask you what is the highest degree of x, so you see highest degree of x is 3. So what is the linear factor associated with x raised to the power 3? So it's 1. So 1 cannot be 0. So we cannot find the right parallel to x-axis, the asymptote parallel to x-axis we cannot calculate, but the asymptotes parallel to y-axis can be calculated. Now you see the highest degree of y, it is y square. So coefficient of y square will be, you see, x minus a. So when you put x minus a to 0, right, it becomes x equals to a. So this is the asymptotes parallel to the y-axis. So what I told you before, there is no asymptotes parallel to x-axis. So you see the solution of the first part. Just take the screenshot and appreciate it. Similarly, now we can talk about the asymptotes parallel to the coordinate axis for this curve, second curve. So here highest degree of y will be how much? So y square, and y square is the highest degree of y. So you can write here y square, take common. So this is x square minus a square. So this will be the linear factor, because you can check it, x plus a on x minus a. So when you put it to 0, so you get x equals to plus minus a. So this is the linear factor, right? This will become the asymptotes parallel to y-axis. You see, these are the linear factors. Similarly, the asymptotes parallel to the right x-axis or y-axis can be calculated. So this is the answer before you, right, on the asymptotes parallel to the coordinate axis. So in the next video, I will talk about asymptotes, right, oblique asymptotes. So I'm writing here oblique, which are not parallel. Okay, there are two conditions in the plane: either the straight lines or tangents are parallel, or they will be intersecting or oblique, right? So that I'll discuss in the next video. So I hope, right, you understand this concept of the asymptotes and asymptotes parallel to the coordinate axis. So if you understand the video, right, I request you press like button and stay connected with the channel. I request you again, please share the video with your friends and subscribe the channel. And also hit the bell icon for the latest right videos and updates. So now I'm leaving. I'll meet you again in the next video. By then, bye bye, take care, thank you.